So, hello and thank you for joining today's webinar. I'm Jordan Sloop, your host from Kentik Marketing. Our topic for today is how to prepare for a peering partner business review. Our presenter is Kentik's Director of GTM Strategy, Nina Bargeson. In today's webinar, Nina will demonstrate how to pick the right topics, collect relevant data, and find your BATNA for your peering partner business review. During the webinar, if you have any questions, feel free to enter them in the Zoom chat, and we will answer as many of them as we can in the Q&A session at the end of the presentation. So I'll pass it over to you, Nina.
Thank you, Jordan. Hi, everyone, and thank you for joining us today to talk a little bit about peering. This is a webinar that kind of comes out of the blog series that I did a while ago about the Peering Coordinators Toolbox. And today we're going to talk about how we can use some of those tools to prepare for a peering review. So because peering is not just about finding new peers and setting up these first sessions. It is also about growing and nurturing that relationship to make sure that both you and your peer are getting the best out of it. And a big part of that is doing regular reviews with the peer to secure that both you and them are happy with what's going on. One of the places that these reviews often takes place is like peering forums that takes place all over the world. Like actually these days right now in Washington, D.C., where I am right now, is because we have the Global Peering Forum. And this webinar is actually a great example on how you could prepare before you went to a peering forum and had these meetings with each of your peers and discussed what was going on. So the first place to start is to make sure that you know your partner's peering policy. And let's take a step back and just discuss what are peering policies. So the basics are, well, there are three kinds of peering policies. There is an open peering policy. You'll peer with everyone where it's possible. There's a selective peering policy. And these selective peering policies are for people who want to peer, but want to make sure they only peer with people where the mutual benefit is satisfactory. And so there's a set of requirements that have to be met to make sure that that is achieved. Often the requirements are reasons you can say no. And again, but the purpose of having a reason to say no is that these networks only want to peer where it makes sense and where for them and where they have that feel that the benefit for the peering is equal on both sides. Restricting peering policy is what we call the policy for networks who peer, but really don't need new peers and generally just decline whenever you try to ask for a peering. If you look into the selective peering policy, the elements that are typical in those are different requirements to traffic and locations. Ratio is a common one that is usually used for people who want to only peer with networks that are like themselves. So the tier ones typically have ratio requirements, but also other carrier networks might feel that they only want to peer with other carrier networks, so they have the same amount of traffic flowing back and forth on the connections. Ratio never makes sense when you have a content and end user network peer, because traffic is typically flowing in one direction, but there still is a mutual benefit, even though it's not the same amounts of traffic going each way. So again, ratio only applies as a mutual benefit to some types of network. The volume requirement is typically because the networks want to secure that the benefit is high enough to pay for the increased workload that creating and maintaining the sessions are. And locations, well, for locations, people want to secure that there's an overlap over the networks so that the traffic is being carried an equal amount of distance within the network. And they can hand off the traffic as fast as possible. Finally, we have the customers of existing peer. It's a difficult one but because it's a requirement to secure that the peer or the network is not upsetting their existing peers by starting peering with some of their customers, and that way removing revenue from the existing peers. Another point that to think about for this requirement is also the traffic of these customers could be part of the ratio or volume requirement. And if you remove that from the connection to that peer, you might not meet that peer's requirement for peering anymore. So your new peering will make you de-peered from somebody else. So it sounds like an unfair requirement sometimes, but it actually does make sense in certain areas for certain networks. So let's do a poll of you here on the webinar. What is your peering policy? So please fill it in. It looks like we have most selective peering policies in the room. And a few who have a restrictive. So nobody, unfortunately, or nobody luckily has a non-existent. So that's great. All right, let's move on. Let's have a look at the analysis that we should start doing as a preparation after we have familiarized us with the peering policy. So things to look at now based on the policy is the routing, the quality of the traffic, the volume and the forecast, the cost, and then finally think about what to do if we can't reach an agreement with the peer on what the next step in the relationship should be. So when we look at routing, it is two things we want to look at. We want to look at how is traffic routed inside your network and how is traffic routed in your peer's network. And for this, the Data Explorer in the Kentik tool is your friend. So let's have a look at the query that we can do. So what we're going to do is that we're going to look at the sources of the traffic, so the source ASN numbers, the site where it's entering into our network, the site where it's exiting our network. That site is called the ultimate exit site in the Kentik. And it's not a thing that we can just read out of the flow, but it's a site that we identify by looking at the flow, the destination IP address, and the routing table for the internal routing in your network. So we need those information to come into the tool, and then we can calculate what the ultimate exit site is. And then we look at the destination ASN. So that is the ASN that we hand off the traffic to. And finally, it's the destination of the traffic. And for the first query that we do, we then filter to the destination AS number. And for this example, we have picked 1299, Aurelian, or Tilia as they were known as before. And this is the data in this example is demo data, so it's fake data. So we just picked this AS number. So let's look at the result. It's coming out as a Sankey diagram. I love those. There's so much information in them. And we can see originally we have two customers that enter traffic into our network. So one of them is Netflix and the other one is Lumen. And we can see that the traffic is entering into our network in our Chicago POP or ID1 and into our New York City POP, New York City 1. Then we carry it all to Chicago, and in Chicago, we hand it over to the peer 1299, and the destination as well is 1299. If we turn the query around and we look at traffic originated in Aurelian and going to us, the picture looks like this. Traffic coming from Aurelian going into our POP in Chicago. It's routed to New York City, some of it, and then handed off to us. And some of it is handed off already in Chicago and then going to AT&T. So that traffic, we are happy with the route. It comes into our network in Chicago and goes out of our network in Chicago. But the New York City traffic is hauled in our network all the way to New York City, maybe that's not so great. So it could be great based on these two graphs to maybe put up a connection in New York City to the pier. So let's now mark that down as a wish for our next meeting. So, but will that also work, do we think, for our pier? So let's try and extend the queries a little bit so that we look at the destination city. So we look at the geo information for the traffic. So in the query, we add in one direction where we're looking at the source ASNs that has destination in 1299. We're adding a destination city. And for the second query, where we look at the traffic going the other way from Aurelian to our network, we're looking at source city to see where the traffic is going. So the result for the first query is, wow, we see that most of the traffic that we get from Aurelian in Chicago actually originates in New York City. We get it in Chicago. They route it to Chicago. We hand some off in Chicago, and we route some of it back to New York before we hand it out. That does not look great. And then we look at it from the other side, traffic from our network and our customers' network. We see that it's Netflix is handing we have a connection to them in New York City. They give us traffic. We route it to Chicago, hand it off to Aurelian in Chicago, and they route it all the way back to New York City. So there is a lot of good reason from both sides, it looks like, to fix. We actually have identified a hairpin issue. So we can translate the Sankey diagrams into this sketch of networks, where we see we have 20 Netflix sitting here as a customer in our network, and then the traffic going to Chicago, back to New York, to end users, and vice versa. At least we have, from a routing perspective, it makes good sense to set up an additional connection in New York City to the pier. What about the quality? Because does it really matter what's going on here? So let's take a step back and see what can we do to measure the quality of the traffic. Well, we can use the synthetic test. Synthetic test is a test you do from an agent that's sitting somewhere in the network, and then you test up against certain destinations. We can see here, you can deploy the agents in your network, and Kentik has a set of agents deployed throughout the internet on a global basis. So you can use those to test targets in your network, and you can use the agents inside your network to test targets outside of your network, for instance, in your peers' network. You can then measure for instance, the quality of the over-the-top services that are on the internet. And you can do it both from the agents inside your network and from agents on the internet. So when you get an alert from an agent that there's something wrong with one of the OTT services, if it's from inside your network, you can have a look at the global tests that are running from the agents from the global agents. And if they're all clean, there's an indicator that something wrong inside your network, and you should start debugging. But if, on the other hand, there are also alarms on the global agents, then maybe it's an internet weather issue, or maybe there's something wrong with the service, and you should direct your efforts into figuring out what that is. So if we take a step back, here is a summary of how you use the two types of network. And then what we can do, it's pretty easy from one of your private agents to set up a test towards one of your peers, because you have your flow data flow data will tell us, and it will tell the Kentik tool, this is the most important targets inside that ASN, and we can use that to automatically decide what the destinations of the test should be and just set it up. The result you can get is like, here is an example where we are measuring path hops and geodistance. And we can see on this result that we actually have like 30 hops in the trace route, and that's a lot. So maybe again, that connection in New York City could be a good idea because it will increase the quality of the traffic for our customer and then the happiness for our customer. So we should be willing to go a long way to get that connected. The next thing to check is the volume, because you want to understand how is the traffic growing. You want to make sure that you meet the requirement in the peering policy to a volume, if there is a volume requirement. So how can we do that? And also, of course, to make sure that you have the right capacity on the connections to your peer. In the Kentik tool, we have some really good on a per interface basis capacity planning tools. And this is the screenshot from the two connections, the one connection to the peer in either direction, inbound and outbound. You can see inbound here. This down here is the outbound. And then we have also checked, or have taken a screenshot of the customer interface as well. So first, let's have a look at the peer interface. And we see that the growth in the inbound direction is 2 megabits per second per month, and it's 5 megabit seconds per month on the outbound direction. And we have a 10 gig interface, and we're using less than 2 gigs. So even here, we would also have an alarm on. We can see it takes over a year before we run out of capacity on this interface. So we see there's not really a volume requirement for an upgrade or for a new connection. So that means our argument for building another connection is going, well, there's a little bit less reason. So we have to take that into account. A double check is that we want to check that the same growth numbers are on the customer interface, just to make sure that we're not getting the customer growth is being blended into too much other traffic on the peer interface. So we are getting a wrong sense of the growth of the traffic that will be on the interface in New York City. But the conclusion is we do not have a volume requirement. So we have to put that in our back of the head at this point. Finally, we have to think about that again. It has an effect on the cost of an additional interface. Because right now we know from our cost tool, which is described in more detail in the blog series that I talked about earlier, that the cost per megabit for this connection to Aurelian is $0.66. Well, it's 66 cents per megabit per second. And because the traffic is not growing a lot, that actually means that building another connection will increase the cost of traffic to this customer, or to this peer, sorry. So we have to think about, is that worth it or is it not worth it fixing the hairpin issue that way? The conclusion here in our example is that it is worth it, because the cost we have is only the cross-connect cost and the interface cost. It is a free peering. So if we can persuade the peer to set up this connectivity on these terms, it will make sense to do so. We haven't talked about what kind of connection it is, but if we look at the cost tool, it is a private connection we have to this peer that we have chosen as an example. But there is also public peering, as you know, over internet exchanges. And typically, it is also a topic that will be discussed in a peering business review, because If you're on a public exchange, maybe the traffic growth and the volume of the growth of the traffic to this particular peer will mean that you have to upgrade your interface, your whole interface to the internet exchange. And for me, that's always been a good time to start discussing, should we move this traffic off the interface and then onto a dedicated interface, which is what a private peering really is. And once you do that, you have to think about what is the capacity. And then we always run into where are you and where is the peer in the evolution of your network. So we have right now in these days, we have 10 gig interfaces, 100 gig interfaces, and 400 gig interfaces. And some peers still use 10 gig interfaces, but some peers actually have gone out and say, well, we're not using 10 gig interfaces anymore. It's not an interface that exists on our equipment. So if you want to connect to us, it has to be 100 gig or 400 gig. And for, like in this example, we have 2 gigs of traffic. 400 gig definitely doesn't make sense. 100 gig probably does not either. So again, here you have to think about, well, even though it makes sense for me to move that traffic to a dedicated interface, I can't get an interface of the right capacity, so I will have to stay on the internet exchange. Another argument is that maybe you can connect on the internet exchange. You're both on that, but it's the internet exchange that is creating the connectivity from the data center where your POP is and the data center where your peer is. So if you do a private connection, maybe one of you will have to pay for a Metro Connect. So again, have to think about what it is you want, but also try to evaluate what does the peer want when you're preparing for the review. Finally, the last thing to think about is the BATNA. What is the best alternative to the negotiated agreement? Is it good enough to just leave things as they are? Or maybe we really, really want to fix the hairpin issue, and then maybe we should move to transit. And what do we think the peer thinks? Would they be happy with how things are, or what? Anyways, I think in this case, I would go out and I would see what kind of transit could I get in the New York City area that could carry the traffic on a more direct path than me hauling it to Chicago and hauling it back. And the Kentik Market Intelligence tool is a great tool to find a transit provider that will have a lot of routes from the New York City area. So we have drilled down the ranking of the internet of the transit providers, which is based on the carried address space. So we're drilling it down to New York, and then we get a ranking, and we can pick one of the top ones that carry a lot of space from the New York City area. And then we have that as our BATNA. So conclusion, we have a game plan. We have identified a routing issue. We have documented it. We have documented the consequences. We can see there's a lot of hops. There might be a higher latency going it that way. And the solution would be a new connection. We've also realized that we do not have a volume requirement. We do not need more capacity. So adding another connectivity will only be justified by fixing the hairpin issue. Maybe the peer doesn't think that's important, so we can offer to pay for more cross connects. We can offer to maybe use an IXP instead of using a private connection. And finally, we have found a alternative to the connection, which could be to buy local transit to carry exactly that traffic. And then I'm reaching the end of what I have to say. Are there any questions?
Yeah, thank you, Nina. That was a great presentation. We do have a few questions that actually came in. So the first question is, are the Sankey diagrams and the analysis showing the full path to destination ASNs?
That's a great question. And actually, it's not. If we go back and we have a look at one of the diagrams, Yeah. So we can see what we do is that we have only put in the next hop ASN and the destination ASN in our query. That means that we don't really know what's happening. If we take, for example, on this graph, we don't know what's happening between Pixnet and I actually can't see and AT&T for the traffic that is coming out of Kentik that we are handing off in Chicago. Because we've only taken the handoff ASN and the destination. The path here could be very long. We do not have that visibility in this query. We could add more ASNs, but we're not sure we would be adding all of them. So that's a good thing to keep in mind.
Great. And the next question is, are the synthetic agents in the Kentik platform hardware probes, and are two enough?
No, they are based on software. So the probes is a piece of software you can download and install into VMware on your own platform or on your own little small servers or whatever. We are not shipping hardware out. And it's the same code that we use on the global probes all over the world. So you will get the exact same functionality on the global agents as you have on private agents and vice versa. But it's code and a piece of software that you download and not a hardware piece.
Great. Next question is, are there other things we need to check if we needed to select the transit provider for the New York City traffic?
Yes, there's actually a word of caution here because, as I said, the ranking is based on the address space from that geography. So the providers in the ranking is those who have a lot of space from the New York City area, address like IP addresses. But you have to go and check either by asking the sales rep or by looking into the looking glass that there is a short path from the transit provider and to your peer in New York City. And so you're not creating just another hairpin issue if they're connected somewhere else. So that's a good question and a good thing to be cautious about.
Awesome. Well, it looks like we've just about come up on time. So we'd like to thank everyone for joining in today, and we've covered a lot of material. So this webinar was recorded, so you can review a replay of it on our website, that's kentik.com, and please share it with your interested colleagues. In the next couple of days, you'll get an email from us so you can review the content, get a link to the recording, and get any other additional information you'd like. If you have further questions, please email us at webinars@kentik.com. And thank you, Nina, again, and we hope to see you all again soon.
Thank you, and take care, everyone.